Probably this is one topic which has bothered a lot of people in software development, including software developers. And the problem is that no matter which programming language or programming paradigm you are using, if you do not understand it, you will not be able to make use of it. Because name a programming language, you can create concurrent or parallel programs. So it's good to know about it. So let me try to explain this. Now, the idea behind concurrency and parallelism is to achieve the same goal, and that is where it ceases to become a black and white thing, and that is where all the confusion starts. So the intent of concurrency and parallelism is same, which means doing multiple things together. But there is some difference. It is similar to saying that if you want to go from point A to point B, you can take a bike, you can take a car, you can take a bus. All modes of transport will take you from point A to point B, but there is a difference between modes of transport. The same difference exists in concurrency and parallelism, but the intent is same, just as the intent was same for me to go from point A to point B. Now, let's first talk about the parallel part of it. Parallelism. What is the meaning of being parallel? So let's assume that I have 5 tasks, right? At any point of time in your system, only 5 tasks are running, and these are those 5 tasks. And there are 5 CPU cores or different CPUs are available. Okay. So you know that each CPU can do only one thing at any point of time. If you want to run multiple things, you need multiple cores or multiple CPUs. And if all of these tasks are associating itself with each and every CPU, so there are 5 tasks and 5 CPUs, and each task is executing in a particular CPU, then this is running in parallel. All the 5 tasks are running in parallel, independent of each other, right? One cannot impact two, two cannot impact three, and so on and so forth. So this is what the meaning of parallelism is. Okay, so running things in parallel. And when you talk about parallel programming, both multi-threading and multiprocessing fits in this particular scheme of things. Okay, so when you create multiple threads, same situation happens. When you create multiple processes, same situation can happen. Now, till this point, please make an assumption that number of tasks, number of threads, or number of processes is equal to number of cores available, and that's how it is parallel. Now, in today's machines, cores will be limited. It will be, 32, 64, 128, but the number of threads can go beyond that, or number of processes can go beyond that. So, not all things will run simultaneously at the same time, which means that it will be restricted by number of cores we have in our system. Now, let's talk about concurrency. What is the meaning of concurrency? Let's again say that we have 5 tasks. But at this point of time, we have only 2 CPU, and all of these 5 tasks, if they have to execute, they will execute on a particular CPU. So they need to use one of these CPU at any point of time. So in this particular case, what will happen is that all tasks will be running. Okay, all the 5 tasks will be running, but may not be running at the same time. Because there are only 2 CPU at any point of time, only 2 tasks can run. So let's see an example. Okay, so at any point of time it can happen that task 1 and 2 are running in CPU 1 and 2, 3, 4, 5 are waiting. It can change where 2 and 3 are running now and rest of them are waiting. It can again change at some later point of time where 4 and 5 are running, and similarly it can change where 1 and 2 are again running, the rest all of them are waiting. Now, this is called concurrency. Concurrency means all the tasks are running at the same time, but the difference between parallel and concurrent is that in parallel processing, the task doesn't stop in between. One CPU takes the task. Ideally, if you think from the perspective of what happens within the hardware, everything is concurrent, right? It's not that one thread takes a CPU for the whole time unless until you write a while true loop. But from the concept perspective, one thread can execute in one CPU and nothing will, stop that. But in this particular case, there will be, time scheduling between all the tasks. And there can be multiple reasons to give you scheduling, like, some tasks are waiting for user input, some tasks are waiting for HTTP fetch or, connecting to network socket. And by that time, you want to do something else. And that's where task scheduling happen. And that is how the concurrent scheme of things works. In concurrency means task will be running, but at the same time, it can be preempted for doing something else. And preemption can happen either by the operating system or by the program itself. Think about async IO, the asynchronous programming, where we just fire and forget and wait for it at some later point of time. That's a kind of concurrency we programmers used to handle. Okay. So now when we are talking about concurrency, there is one special case I need to mention, which is about the most popular language as of today is Python. Python has something called GIL, which is Global Interpreter Lock, which means that at any point of time, only one thread can work or run. Okay. Which means that if you create multiple threads in any other programming language like C, C++, Java, C Sharp, and many other languages, the chances of them running parallelly is high based on the availability of CPU, and it may run parallel as well as run in a concurrent way. And even when it is running in a concurrent way, it will use, at least two, three tasks will be parallel based on the availability of CPU again. But in Python, all threads will be concurrent because there is only one thread of execution at any point of time. So in case of Python, again, if you have five tasks, only one task will be running because only one thread of execution. Please don't get confused by CPU number one because it's not that only one core will be used. The thread of execution can be running in any core. If you have 12 cores, 16 cores, it can run in any core, but it will be using only one core at any point of time. But if you create multiple processes, then you will get real parallel behavior in Python. So just thought of touching on this particular topic. I do hope and believe that the topic of concurrency and parallelism is clear to all of you. Thank you all. Thanks for watching.